RCHUB International Foundation for Research and Education, and ISO certified.
So, so during the last session, let me try to recall. I have illustrated what the statistics is all about. So we have understood that we are performing statistics only to for 5 reasons: to describe a data set, or to find a significant association between the variables, or significant relationship between the variables, or significant influence of one variable or another variable, and significant difference between the variables. It is for these 5 reasons we are performing the entire statistics. And I also have taught you what statistics need to be performed. And finally, we have also discussed about how to feed the questionnaire into SPSS. So today, let's start performing the analysis. Let me start with a very fundamental analysis, which is known as a descriptive statistics. So what this descriptive statistics is all about. So descriptive statistics, let me open a word. Okay. So let me share my entire screen. I hope the entire screen is visible, right?
Yes.
Okay. So we are describing descriptive statistics. Descriptive statistics. So when we talk about descriptive statistics, it could be easily described as mean, median, mode, and standard deviation, skewness, kurtosis. So all these together creates a descriptive statistics. So what this, let me increase the font size so that it will be visible for everyone. So what is this mean? Mean is nothing but the average value. Mean is nothing but the average value. And median is nothing but the middle value. And mode is nothing but the most repeated value. And standard deviation is how far the value is getting deviated from the central value, that is mean value. Skewness is measure of skew is nothing but whether say for example, you being a teacher, I'm giving you an examination in which the question papers are made in a very tough way. So what happens, many of the students will be getting scores less than 50 marks. So the most of the points will be between from 0 to 50. So this is what is called as the negatively skewed. So it's in the less value, right? So what is the next is that in case if I set the question paper in a very easy way, most of the people will be getting marks, very high end marks. They will be getting marks above 50, 50 to 100. So there the points will be concentrated. So this is nothing but the measure of flatness. And this is nothing but the measure of peakness. So this is what is called as descriptive statistics. So as simple as this. So no need to get confusion. So now let us try to understand how these descriptive statistics could be done. So apart from this, the another type of important descriptive statistics is nothing but percentage analysis. Percentage analysis, cross tabulation, as well as the diagrammatic representation. diagrammatic representation of these metrics. Now let's see how to perform these descriptive statistics. So descriptive statistics, I hope you have understood what this descriptive statistics is all about. All the components of descriptive statistics is all only this. If you consider variance, it's nothing but the square of the standard deviation. So no need to worry about that thing at all. So these are the main components. So let me explain you how to perform a descriptive statistics. Let me start with the simple percentage analysis and cross tabulation and diagrammatic representation. So let's perform this followed by the other things. Okay. Let us perform this followed by the other things. So let me consider the same data set. So yesterday we made a questionnaire, right? Gender, age, education qualification, current occupation, area of residence, monthly income, how often you purchase the beverage, how much ml of bottle you often purchase, reason for your purchase, fresh fruits, from where you purchase, is it from bakery or grocery or dairy? So all these is this set of questionnaire we have seen yesterday. So what I'm going to do is that I'm going to perform a simple percentage analysis for the demographic profile that is D1 to D4. So in order to do that, in order to do that using SPSS, what you have to do is that you simply have to click analyze. Once you click analyze, then you go to the descriptive statistics. Once you go to the descriptive statistics, click on the frequencies. Click on the frequencies. So once you click the frequencies, this is the window that will appear. In the window, you have to select the variables for which you need to perform the percentage analysis. So in order to perform a percentage analysis, all the data has to be categorical, because if it's metric, you won't be getting a proper values. So I'm going to consider gender. I'm going to consider the education qualification, and I'm going to consider the current occupation and area of residence. I'm telling you why this age cannot be considered for the frequency, the percentage analysis. I will tell you. Let me show also. I'm going to click OK. So in the, if you simply want percentage analysis, what you have to do is that once the selected variables for which you want percentage analysis has been went into this variable section, click on simply OK. If you click OK, in the output window, you will be getting the output. You see, male. Among 499 respondents, 350 were male, 149 were female, and its equal percentage is 70.1 and 29.99. So if you see, if you look at the age, actually I have made into categorization, so which is okay. So then comes education qualification, then comes the current highest level of education and occupation and area of residence. So we have got all these output. I don't want this. This has to be rectified. Okay. So now we got the output. So how to scrutinize this output? So, okay, now you have understood how to perform a simple percentage analysis. In order to perform a simple percentage analysis, what you have to do is that you need to simply click analyze, go to descriptive statistics, click on the frequencies, and select the variables for which you need to perform a simple percentage analysis. Make sure all these are categorical data, and then you simply click OK, you will get the output. So once you got the output, this is my suggestion. Don't copy paste just like that, because some of the values in these table are completely useless for us when it comes to writing an interpretation. And so what you have to do is that you have to scrutinize the data set. As I said before, scrutinize the output. So as I stated before, or in the output file, you can copy paste. So I'm going to copy gender, highest level of education, current occupation, and area of residence. I'm going to copy paste in the Excel. So the thing is that I only want frequencies and percentage, equal percentage. I don't want valid percentage or cumulative percentage. It's completely useless because it is derived. This is nothing but the repetition of it. So I'm going to delete this. So you see here in the table, it has valid. It's all completely useless. If you want, instead of valid, if you want gender, you can click it. I want highest level of education, current level of occupation, area of residence, and I don't want these values. So it is not just, now here I'm going to put it as demographic profile. You see, now the table looks neat, clear, and everything is, what do I say? It's logical. So this is how you have to scrutinize your output. So, okay. So this is how you have to scrutinize your output. So you have frequency percentage of gender, education level, occupation, and area of residence. So neat, right? So now let me explain you how to generate the graph. How to generate a graph for this file. So in order to generate a graph, what you have to do is that once again you need to go to analyze, go to descriptive statistics, go to frequencies. Here in this window, if you want charts, here you will be having a chart tab. So click on the chart tab. Once you click on the chart tab, it will be asking you what kind of chart you want. Whether you want a bar chart or you want a pie chart or a histogram. So histogram is generally used for metric data to check whether your data are normally distributed or not. Here we are using categorical data. So I can use either bar chart or pie chart. So let us first generate the bar chart here. So I'm going to click the bar chart. Bar chart, all the data will be illustrated in terms of frequencies only. Click OK. Now, if you see, you will get the bar chart. Yeah, sorry. Now the chart has been generated. You see, for gender, we have chart that is 70% male, that is 350 male, and almost something 75 or something as female. Similarly, education level, most of them are graduate, followed by postgraduate and other professional degrees. And their current occupation is, since most of them who are buying these are students, so unemployed or something like that. And they belong to urban area. So in case if you want to generate a pie chart, so what you have to do is that once again go to frequencies. In the chart column, select the pie chart, click OK. Then the pie chart will get generated. You see? So this is how you have to generate the chart. So now I have explained to you how to generate, how to produce percentage analysis, how to generate a bar chart, and how to generate the pie chart. So now I'm going to explain you how to generate the cross tabulation. So I have explained you percentage analysis. I have illustrated percentage analysis, diagrammatic representation. So now I'm going to explain you how to perform cross tabulation. So cross tabulation is nothing but comparing one categorical variable against the another categorical variable. So as simple as this. So let me repeat. It is nothing but comparing one categorical variable against the another categorical variable. So I wanted to know, yeah, with respect to gender, what is their occupation? Occupation. Or I can say, yeah, how much they consume, whether they buy the beverage on a daily basis or monthly basis or weekly basis. Who is consuming the most, whether it's male or female? So that I wanted to know. So for that, in order to perform cross tabulation, what you have to do is that you have to click analyze, go to descriptive statistics, and then you have to go to cross tabs. There is a separate tab here known as cross tab. You need to click this. Once you click it, this window will be popping up. This window will ask you what row and what column has to be used as a study variable. So here I wanted to know gender and how often they purchase. I wanted to know this can be interchanged also because the result will not change. The table value will not change. Only the rows and columns will be interchanged. So you can put rows and columns interchangeably. That's not an issue. So I put gender and how often they purchase. I wanted to know whether male is purchasing more frequently or female is purchasing more frequently. So I'm going to click OK. You see, we have got the cross tabulation output. So this is the cross tabulation output. So what it explains, male with respect to among 350 males, 216 male used to buy these beverage on a daily basis. On a daily basis. Whereas, which is highest in number, whereas female, you see, they often used to buy the beverage only weekly once because this is the highest value here, followed by daily basis. Here, the male used to buy the beverage on a daily basis, whereas female mostly used to buy this beverage on a weekly basis. So this is what is our interpretation. So we can say that male purchase this beverage more frequently and on every daily basis compared to female. So we can say that, right? So now we have understood what is this cross tabulation. For cross tabulation, you require two variables of categorical data. Even if you interchange the rows and columns, the result remains the same. And the most important thing is that you may have a question, sir, is there any possibility to generate a graph for these kind of table? Yes, it's possible. So how to do that? To do that, what you have to do is that once again, click analyze, go to descriptive statistics, click on the cross tab. In the cross tab, once the particular rows and the column has been selected, what you have to do is that you have to click display the cluster bar chart. You have to check box this display the cluster bar chart, and then if you click OK, now you will be getting the cross tabulation along with the diagrammatic representation. You see the male, most of them buys on a daily basis, followed by weekly basis and monthly basis, and then finally once in 2 weeks. Whereas with respect to female, they mostly buy on weekly basis, followed by daily basis, and then once in 2 weeks, and finally monthly once. So this is the diagrammatic representation. So now I have explained you how to perform a simple percentage analysis and how to perform cross tabulation and its diagrammatic representation. Is everything clear, ma? So now let's move on to the next important session. That is the mean, median, mode, and standard deviation. So for this, let me open this data set. I think this will be optimal. Okay, I think this will be optimal. Actually, this data set is also original data set, which is conducted for Royal Enfield bike. You see, yeah, yeah. I wanted to know whether the mileage, yeah, actually, this study was actually conducted to check what was the bike's mileage at the time of purchase and mileage. Is there any significant difference in mileage before the first service and after the first service? If there is no difference in the first service, if there is no difference in the mileage in the first service, what kind of strategies they need to implement so that there will be a significant boost in the mileage. So it is for this particular study is conducted. So I told you, right, generally, you cannot perform percentage analysis for a metric data. You see, all these values are percentage. All these values are numbers, metric. If we do a simple percentage analysis for this will be the output. Yeah, bike mileage at the time of purchase. You see, 36, 37, 38. If you see this particular yeah, if you see this particular percentage analysis, you have a clear picture. Housewife who purchasing housewife are 44 in numbers, students are 36 in numbers, self-employed. But if you look at this particular thing, data set, it's a little bit clumsy. It's a mileage. It says that two bikes are giving 36 as a mileage, four bikes are giving, but this is ridiculous. In case even the number is not repeated, it won't sound good. So this cannot be applied for percentage analysis. Metric data cannot be applied for the percentage analysis. So at the same time, these kind of metric data, through this metric data, we can check whether the data are normally distributed or what using diagrammatic representation. How? Using this uh, using this chart. So what chart in the sense histogram. So it is for this, they are generally used. Yeah, we see almost the data are normally distributed. Most of the data falls under the curve, normal distribution curve. So it is for this, this graph is generally used. So, okay, now let's come to the point. Now let me come to the point. So now we are going to discuss about this mean, median, mode, standard deviation, skewness, and kurtosis. Okay. So I wanted to check at the time of purchase of bike, what is the average mileage? Let me do it. Let me do it. In order to perform descriptive statistics, go to descriptive statistics. Select the variable. I wanted to check what is the bike mileage at the time of purchase. And in the option, there is a tab called as option. In the tab option, I'm going to select the things what I really wanted. I think this is not suitable. Let me go to frequency itself. Yeah, I'll go to descriptive statistics, click on the frequencies, select the bike mileage, and in the statistics, there is a tab called a statistics. Click on the statistic tab, select the things what you wanted to know. I wanted to know the average mileage of the Bullet Classic 350. And I wanted to know what is the mileage of the middle bike. And what is the mileage, most repeated mileage? What is the most repeated mileage of the bikes that has been purchased? And I wanted to know what is the maximum mileage, what is the minimum mileage, what is the standard deviation, and what is the skewness, and what is the kurtosis. So now I'm going to click OK, or click continue, and then I'm going to click OK. So now I have got the output. You see, this is the output. This is the output. Let me copy paste. So let me copy paste. Uh, Let me increase the font size. I hope the font is visible. Is my font visible? Is my font visible to everyone?
Yes, it's visible.
Okay, ma. So now what we are going to do is that let me copy paste these values also. So I told you, right? Mean is nothing but the average value. Mean is nothing but the average value. Average value. So now let's check whether what is the average value. So for that, I'm going to simply use the formula equal to average of all these value. What is average? It's summation of all value divided by the number, n number. Here there are 20 bikes, right? So you see 38.6. You see these two values are same. You see these two values are same. So this is what is mean. Mean is nothing but the average mileage of all the bikes. So now you have understood what is the mean. So now let me do for median. Median is nothing but what I told, median is nothing but the middle value. Median is nothing but the middle value. So what I'm going to do is that I'm going to sort these values. I'm going to sort from smallest to largest. Okay. So I'm going to sort this from smallest to largest. So now I have sorted it out. Now, if you take a close look, this is 1, this is 2, this is 3, 4. So there are 20 values. So when comes 20 values, there are two middle values, right? There is two middle values. There is two middle values. 9 above and 9 below. There are two middle values. The average of these values is once again is nothing but 38. So that is what is being here. So that is what is here. You see? So median is nothing but the middle value. So in case if you are a little bit lazy and you don't want to check the mileage of all the 20 bikes, instead what you will do is that you will arrange all the bikes on the first come first based. So on the mileage base, and you will select the middle one, right? You will simply select the middle one, and whatever mileage it is giving, you assume that all the bikes are giving the same mileage. So that is what it is. So the median is nothing but middle value, which is 38. Mode is most repeated value. Let's check it out. You see 38 is the most repeated value. It is repeated for 1, 2, 3, 4, 5 times. Whereas 39 is repeated for 4 times. And 40 is 1 time, 41 is 2 times, 42 is 2 times, 37 is 4 times. So the most repeated value is 38. So that is what is here, mode, most repeated value. So most repeated value. Standard deviation. So if 38 is the value, if 38 is a value, how from 38, how far the value is getting deviated. So if you see most often, I'm not considering to the extent, but most often you see from 38.6, if you add equal to 38.6 plus 1.81, it will give you almost 40 point something. So from the middle value, it is getting this much deviation. Similarly, if I put minus here, so 36.79. So you see the 90% of the values is being covered here. Only two values that is we say in the it's in bell curve. Most of the values are concentrated here only. So that is what is standard deviation. How far the value is getting deviated from the central value. And the skewness has to be less than 0.3. If it is not less than 0.3, then we can say that it is not much skewed enough. So if you take a close look, yeah, so we can say that if the value is if a value less than 0.3, we can, or less than 0.5 also a little bit acceptable, but it's, which means here it's not skewed enough. Center it is little bit high, and the it's almost, it's not properly skewed enough. Is the skewness in the sense? Yeah. So generally the data will be normally distributed like this. Whereas when it comes to skewness, it won't be like this. It will be like this. This is what is negatively skewed, or like this sometimes. So positively skewed. This is one, the first type of skewness, and this is two, the second type of skewness. This is normal distributed curve. Okay. So generally, as I stated before, if I this is x and y axis, x and y axis. So let us consider these as marks. So 10 mark, this as 50 marks, and this as 100 marks. So when I keep the questions very hard, what happens is that most of my students will be getting marks below 50. Very, very few will be getting the marks above 50 to 100. So this will be the my curve. This is what is called a skewness, which means if the values are is greater than 0.3, we have to say that it is skewed. It is skewed either left side or the right side. And that is what is this skewness is all about. Here it's greater than 0.5, which means it's skewed. And similarly, the peakness value should be falling under 0.1 or even 0.3 in certain cases. So here, if you take a close look, it's once again, you see it is minus 0.5, it is less than 1, which means okay, there is no much peakness. Yeah, there is no much peakness here. It's from the 36 to 42, there is no peakness here. But if you consider in stock market, some stock prices will be moving in a regular manner, that is, it will be traded at one day of 400 rupees. But suddenly, due to some political reason or some changes, the 400, the stock prices will jump to 600 or 700, and once again fall back to 400 after a while. So this kind of jump, what is happening makes this peakness. Here it is, there is no such thing. So that's why it is between zero point 0.1 to plus or minus 0.1. So here it is, there is no kurtosis. So this is how you have to interpret the descriptive statistics. So I have explained to you what is mean, what is median, what is mode, what is standard deviation, what is skewness, and what is kurtosis. So all these together is nothing but the descriptive statistics. So as simple as this. So now let's move on to the next session. That is the important thing. That is significant association test. So I hope you all remember, for in order to perform significant association test, the important conditions, yeah, the important conditions are the two variables considered must be categorical in nature. This is the first important condition for significant association test. The important condition is two variables must be categorical in nature. Categorical in nature. And what test you need to perform? Either the chi-square test or the Correspondence analysis. So now let us try to perform. Now let's try to perform a significant association test. So in order to perform significant association test, let me consider the very same data set, this one. So yeah, we can do with the same, right? This is also categorical data, gender, and how often they purchase. This is also categorical data, daily or weekly, once in a 2 weeks. So yeah, let's perform association test. So in order to perform chi-square statistics, so is descriptive statistics, is everything clear, ma? So yeah, don't worry, let me try to complete 10 minutes before. So if at all, if you have any doubts, feel free to ask me. Okay. So, so yeah. Uh, in order to perform the chi-square statistics, what you have to do is that you need to click analyze, go to descriptive statistics once again, and then you have to go to cross tabulation, just like what you did before. Click on the cross tab. Yeah, select the same variables. Select the variables. And what you have to do, the main change is here, statistics. Click on the statistics tab. It will ask you what kind of statistics need to be performed. Check box the chi-square statistics. And for since it's a nominal data, well, the best, these are nothing but the methods, different methods to perform the chi-square statistics. Let me use phi and Kramer value. This is the best method for categorical data. But all the things for all the result will be almost same only. Okay, then I'm going to click continue. If you want chart, you may check box. If you don't want, okay, leave it. And sometimes the guide may expect, because when it comes to chi-square test, you have to show both observed and expected reading. But when it comes to, if you're going to show the output file of the SPSS, the expected reading is not required. But in case if you want expected reading, you can check box. Let me showcase the chi-square statistics without expected value. Then I will show you with the expected value. Okay. So I'm going to click OK. So what I did, I have clicked analyze, went to the descriptive statistics, click on the cross tab. I got this window. I got this window, I click the statistic tab. I check box the chi-square statistics and find the phi and Kramer's value. And I'm going to click OK. So now I got the output. Now I got the output. You see, this is the output. This is the output. Let me paste it here. Okay. Yeah. Don't just simply copy paste the output file into the Word document and simply write the interpretation. Make it neat, and then you copy paste into the Word document so that your thesis or dissertation, whatever you're doing, will looks good. It doesn't have unwanted tables. So now this is the output. This is the output. So here, the two things what you have to look at is this one, this one, and finally this one. So The first and foremost is this one. I say this because when you are performing the chi-square statistics, you have to make sure that none of your cell is having the values less than the expected count. If the number of cells is greater than 20% here, your chi-square statistics result is useless. Your chi-square statistics result is useless. You should not use that result. So it should be 0% or less than 20%. And once you've seen that, yes, now our table is useful because it's less than 20%, it's 0%. All the cells is having the value greater than the expected count. All the values are greater than 5. So that's good. The cross tabulation value or all are greater than 5. And then what you have to look at this is the value 0.000, the significance value. When your value is less than, 0.05, less than, greater than, null hypothesis rejected, accepted. So this is it. So here we can say that the significance value is less than 0.05, which means the null hypothesis is rejected. So what is null hypothesis? There is significant association between male and female purchase frequency of beverage. But since it is rejected, the null hypothesis, what is null hypothesis? There is no significant association between the male and female purchasing frequency of beverage. But since it is the null hypothesis has been rejected, what is the accepted hypothesis? The accepted hypothesis is alternative hypothesis. What is alternative hypothesis? That is there is significant association between male and female in purchase frequency of beverage, because you see these are the highest in numbers, the daily and weekly, okay. But if you look at the next values, after the male, the next set of people who is accepting that they are buying the beverage is 63, that is weekly. Similarly, for females, once again, these two values are greater in number. So, or they have association in the frequency of purchase. So that is what is the result. So this is how you have to make the interpretation. So first look at whether all the values are less than the expected value. So then look at the significance value. If the significance value is less than 0.05, reject the null hypothesis, accept the alternative hypothesis. The null hypothesis always say there is no association, there is no relationship, there is no significant difference. So what is the hypothesis here? There is no significant association between the male and female in the beverage purchase frequencies. But it has been found out that yes, there is association. Most of the male and female used to buy this beverage either on daily basis or weekly basis. So that is what is our interpretation. That is how you have to write the interpretation. First, you have to tell the significance value is less than or greater than. Then you have to explain whether your null hypothesis is accepted or rejected. Second, and third, you have to discuss the table value, the cross tabulation values. So this is how we have to write an interpretation. So I hope you have understood how to perform the significant association test using chi-square test. The correspondence analysis. So correspondence analysis could be done only in a place where you have where you have options greater than 2. Here you see there are 5 options. Here you have only 2 options. For this you cannot do. So let me consider the same. The highest or the occupation. Yeah, let me consider occupation. Occupation and how often they purchase. So how often they purchase? Go in order to perform correspondence analysis, go to dimension reduction, click on the correspondence analysis, select the variables. Select the variables. Say for example, here I'm going to select yeah, let me consider area of residence also. It has one, two, three values: rural, urban, and semi-urban. And similarly, the purchase frequencies. It has 4 options, right? It has 1, 2, 3, 4. Yes, it has 4 options. 1 to 4. And if I click OK, you will be getting result along with the output. You see? Yeah, most of the people in rural areas buys it monthly, and in semi-urban area they buy weekly. Who are in urban area, they buy on daily basis. Beautiful result, right? With a diagrammatic representation. You see? You have also got the significance value, that is chi-square significance value here. It is less than 0.005, which means the null hypothesis is rejected. So null hypothesis rejected means there is significant association between the purchase frequency and the area of residence. So if you take a close look here also, yeah, most of the people are buying on a daily or weekly basis. So that's the thing. So this is how we have to do the significant association test. So I hope I have made it clear. So now let us move on to the relationship test. Significant relationship test. So here the conditions are both the variables has to be metric in nature. Both the variables has to be metric in nature. Metric in nature. And for this, you are going to use Pearson correlation. For this, we are going to use Pearson correlation. So I have a data set here. You see? Actually, this is the data set I have collected from EPIDA website. EPIDA means MEPIDA website, Marine Product Export Promotion Council of India. So here I have the total data set. Total data set in the sense to which country how much metric ton of seafood product is been exported. Say for example, frozen shrimp. How much metric ton we have exported during the year, a particular year, and how much in terms of crore rupees, the same frozen shrimp, how much crore rupees we have exported. So we have all this data. I wanted to know the is there any relationship? Is there any relationship between the uh, total export, the total export in metric ton, with the total crore rupees? I wanted to know how far the export values in quantity in measured in metric ton has any relationship with the rupees. So I wanted to know that because you see both the variables are numbers. You see all these are numbers. So in order to do this, what you have to do is that you need to click analyze. You have to click correlation analysis, click on bivariate. Once you click the bivariate, you will be getting this window. In this window, you have to select for which are the two variables for which you wanted to do the correlation test. So I'm going to select total metric ton and the rupees, the total crore, where is that? Yeah, total crore rupees. I'm going to click OK. So now let me see the output. Oh, that's great. You see, this is the output. This is the output. So this is the output. Let me increase the font size. So here also what you have, the same thing applies everywhere. The same thing applies everywhere. Let me copy paste it here. Okay. Here, first what you have to look at is the significance value. First, you need to look at the significance value. This is the yellow color, whatever I'm highlighting as dark yellow, that is the first thing what you have to look. The second thing is the green color. The second thing is what is this value. This is what you have to look at next. And then only we can say whether the null hypothesis is accepted or rejected. So what is a null hypothesis here? The null hypothesis is there is no significant relationship. So you see, there is no significant relationship between the total quantity of marine products exported with the total crore rupees generated from exporting the marine products. So this is what is our null hypothesis. But if you take a close look, the significance value is less than 0.05, less than 0.05, which is 0.00, which means the null hypothesis is rejected. What is the alternative hypothesis? Alternative hypothesis is there is significant relationship between the total metric ton marine products exported with the total marine products total revenue generated in crore rupees from the marine products exported. So how far there is a relationship? For that one, you have to look at this second value, that is 0.964. If the value is greater than zero point 0.9, then we can say that there is strong positive correlation or strong positive relationship between the two variables. If the value lies between 0.75 to zero point 0.9, then at that point of time, we can say there is positive relationship. If it is less than 0.75, say for example, 0.5 to 0.75, we can say there is a weak positive relationship. And if it is less than that, don't worry, there won't be any significant relationship here. The significance value will be less than, it will be greater than 0.05. So this is the scenario. So this is how you have to interpret the relationship. This you can not just limit to the two variables. You can do it with 3, 4, and as many variables as possible. But the only criteria or the condition that you need to follow is that the both the variables has to be metric. So I think this is more than enough for the day. So tomorrow we'll be discussing about the significant uh, impact, influence test and significant difference test. So today we have discussed about descriptive statistics. We have discussed about significant association test using chi-square and correspondence analysis. And then we have also have discussed about the significant relationship test using correlation analysis. So do anyone have any doubts in today's session, ma? Is everything clear? Anyone, any doubts? Yeah, you can unmute yourself and ask me, ma, if at all, if you have any doubts. So can I assume that I have made everything clear? Yeah, there is one message. Could you explain the interpretation of kurtosis test? Yeah, okay. Let me do it with the same data set. Yeah. Let me consider this one, ma. Let me consider this one, this data set, and let me do descriptive statistics, frozen string. Uh, or yeah, let me do it for total metric time. Sorry, sir. Yeah. Yeah. Once again, the kurtosis values falls under minus 0.1 to 1. Okay. Okay, let me try to explain. In case if it is greater than let's say for example, it's 1.9, it doesn't falls under minus 1 to plus 1 category. At that point of time, we can say that there is a very peak value here in this table. But if you take a close look here in these values, the values ranging from nearly 29 lakhs 62,777 to it moving to 13 lakh 92,559. But on the whole, it is increasing in a very linear fashion. And the thing is that there is no exponential hike somewhere in between. Somewhere in between. Say, consider this as a stock price. But instead of this 1392559 somewhere here in the down, it is in the middle. It is in the middle. And some of these values are in the middle. And once again, the same values, the first values is been repeated here. At that point of time, we can say that there is a peakness. Let me open the paint. So this is the day. This is x-axis and y-axis. So say for example, the stock price. The stock price, this is 100 rupees. Yeah, 100 rupees. So the stock price is moving at some fashion like 96, 94, 92, 91. But somewhere due to some political pressure and something happening due to change in CEO, a sudden increase have happened in the stock price. The sudden increase of stock, but once again it started to fall down, and then once again it started to regain its momentum, and then it started to move on. So this peakness, it have moved to nearly 200 rupees. So this is what is the measure of kurtosis. If there are one or two spikes in the normal distributed curve, then the kurtosis value will be greater than plus 1 or lesser than minus 1 at that point of time. So this is what will happen. So do you understand this kurtosis? So this measure of peakness is called as the kurtosis. It is for this the kurtosis is been done, ma. Have you understood? Okay. So, any other questions? So, can we wind up? So this is my suggestion. The thing is that whether it's an application or any skill set, yeah, regression analysis tomorrow I will be explaining you. It's nothing but a next version of correlation analysis. When there is a good correlation between the two variables or the variables considered for the study, one should act as a dependent variable and other should act as an independent variable, and then you can move on with the regression analysis. That I will be explaining it tomorrow. That is what is significant influence test or impact test, and followed by the significant difference test that I will be teaching you tomorrow. My suggestion is that you all have to practice it. Okay. So practice with your own data set for with the analysis, what I taught you right now, and try to practice it for not just for time being, for time to come, so that it will be staying in your mind. Okay. So I think this is more than enough, Ma. So if at all, if you have any questions, please feel free to ask me during the next live session. Okay. Thank you all. Thank you, God. We see. Take care. Bye.
Contact RCHUB International Foundation for Research and Education. WhatsApp 9888 231 231.